Hello students, good morning. Today we will going to discuss about the introduction to the analog filter. Filter is a nothing but there is a something to be happen or to remains is the upper part, and something should be going passing to the next part, which is called as the filter. But in case of the electronics, we have to be just to introductory how to design and what is the basic concept behind the analog filter. That part today we have studying here. Then what is mean by the filter? In filter, basically the background first we have seen here. The filters may be classified as the either digital or analog. Digital filter are the implemented using the digital computer or the special purpose of the digital hardware, and in case of the analog filter may be classified as the either passive or active. Just a minute, I take a one highlighter or the pen here to taken here. The active filter, basically this is the active filter, and from the active filter is analog filter may be classified as either passive or the active, and are usually the independent with the resistance R, L and C component, and it's the operational amplifier, which is called as the analog filter. Means a digital filter are implemented using the digital computer or special purpose of the digital hardware, and in the analog filter may be classified as the passive analog filter and the just a minute. Here to see the basic classified, it is the passive or active, and usually implemented with the R, L and C component and the operational amplifier. Then here in case of the active filter, it is the one important thing about that. In the active filter is the one that along with the resistor R, L and C component, which is available itself, and it contains the energy source, and such that is derived for the operational amplifier, which is the op-amp, which generally it is called as the op-amp. And in the passive filter is the one that contains the R, L and C component, but it is not necessary that all the three be present. In the L is often omitted on the purpose from the passive filter design because of the size, cost of the inductor, and they also carry along with the resistor R that must be included in the design. The analysis of the analog filter is well described in the filter textbooks. There is the most important included the Butterworth and Chebyshev or the elliptic method, which is come into the analog filters, and the synthesis is realized in analog filter. That is the way to build the topological layout of the filter received the significant attention during the 1940s. Here is the basically in 1940s and the 1960s, 1940 and 1960s, and leading the work where the Causer and the Tuttle, since that the time is a very little effort than the directed to the analog filter realization. Then generally just speaking about the digital filter, we have come the focus of the attention in the last 40 years. There is interested in the digital filter started with the advent of the digital computer, especially for the affordable PC and the special purpose signal processing boards. The people who lead the way in the work, the analysis part, there is a Crasser, Gold, Radar, etc., where we have to be use the digital filters. But the digital filter is simply implemented of the following equations in the with the help of the computer softwares and some hardwares. It is also essential to manufacturing of the digital filters or a digital hardware, digital technology is able to use there, and there are no R, L and C components. Such component will be used in the digital filters. Means in most of the time what happens in while you have to be design the digital filters, there is software is required, software is necessary for design of the digital filters. Means somewhere hardware component is may be required, but almost there is nothing to be required for just like the resistor R, L and C component. However, the digital filter can be built directly into the special purpose computer in the hardware form, but in the execution is still in the software. So in this course we will be concerned about, in this topic we have to be concerned about that what is the impedance matching, or what are the different parameters of the Z parameter, H parameter, and beyond that we have to be seen here the filter. So in this course we will only concern with the introduction to the filter, and we look both for the passive as well as the active filters. Then we will not cover any particular design on the realization method, but rather than our understanding of the poles, zeros in the S-plane. So for all the electrical or computer engineering undergraduate students should take the course in the digital filter design. This is my opinion. So we have moved actual deals with you, means which point we have to be learn here. Basically there are the 4 types of the filters, and this is the ideal characteristics, means whatever the low pass filter, here is the high pass filter, here is the band pass filter, and here is the band stop filter. Means your analog filters is basically classified into the 4 types. There is a low pass filter, high pass filter, band pass filter and the band stop filter. In case of the low pass filter, basically we have to be considered here the FL. Here is the FC, which is called as the FC, and FC is nothing but it is the cutoff frequency. And during the cutoff frequency, here the transition should be happen. Means here the low pass filter 0 to the FC, it will be allowed to pass the signal, but upper cutoff frequency there is a transition between here is the frequency with respect to here gain, frequency with respect to the gain or amplitude. With 0 to the FC there is allowed to pass the signal, but after the cutoff frequency your filter should be attenuated or forced to flow the signal into the any circuitry, which is called as the low pass filter. Then we move towards the high pass filter. Same thing here is the lower cutoff frequency. It's basically here we have to be considered about the lower cutoff frequency, or here is the high cutoff frequency. There is a 0 to f of h. Here there is no any signal is able to pass through the signal. Means at a lower cutoff frequency there is your circuitry should be attenuated, or it will be opposed to flow of the signal into the any circuitry, which is called as the high pass filter. And above the cutoff frequency all the signal is able to pass through it into the circuitry. This is called as the high pass filter. Then we have seen the 2 figures. There is a low pass filter as well as the high pass filter. You combine together, and once it will be combined together, then it will be able to form the band pass filter. Just look here. Here there is a white screen. In this white screen we have to be we have to be form the band pass filter and band stop filter. We have to be design it. That part we have seen on the basic foundation level here. Basically what happens, this is the ideal characteristics about that. Here is the low pass filter and here is the high pass filter. Here is the high pass, means here is the 0 to fh, here is the 0 to f of h, means to flow of the signal, means this is able to pass 0 to fc, this signal is able to pass through it. And in case of this is the low pass filter, basically this is the low pass filter. In case of the high pass filter, what happens? In case of the high pass filter 0 to fl, then there is a question is arises in your mind, why here f of L should be given, f of L should be given. The reason behind it, the 0 to f of L means lower cutoff frequency, and here is the higher cutoff frequency. And during the transition from higher amplitude level or higher gain of the frequency of the signal, then here once the transition should be happen for this cutoff frequency, your all the signal should be attenuated, and basically this is the ideal characteristics about it. So here 0 to fH, here initially your signal should be attenuated for this case only. So it is called as the pass band and stop band, which is called as the stop band, SB. Generally it will be represented in the SB means stop band, and here is the pass band, and due to the pass band above the lower cutoff frequency, your signal is able to pass through it. Then after that, once we have to be combine both the circuitry, then particular band of the frequency should be able to transmit it. Means we have to be combine the low pass filter as well as the high pass filter. Means this is the high pass filter. Once it will be able to combine it, low pass filter as well as the high pass filter, then we have to be find out the band pass filter. There is a BPF, band pass filter. We combine both, means band pass filter as well as the band stop filter. Means in band pass filter, the particular band of the frequency is able to transmit it, just like this. Here means this signal is able to transmit it whole FL to FH. Here is the lower cutoff frequency and here is the higher cutoff frequency. So while we have to be designed, which is called as the band pass filter, is the particular band of the frequency for FL to FH only your circuit is 0 attenuated, means pass band only FL to FH the signal is allowed to pass through the circuitry, and which is come at the output of the system, which is called as the band pass filter. Then band stop filter is the just opposite. This is the band pass filter, band pass filter. In the band pass filter, and just opposite to the band pass filter is the band stop filter, band stop filter. Means only FL to FH is the attenuated, whereas all signal is able to transmit through the circuitry, just like this. 0 to FH and FL to above. Means basically here F of L, lower cutoff frequency and upper cutoff frequency, FL to F of H. Means whatever this shaded portion area, this signal is able to allow to pass through the signal. Means only the particular this will be attenuated. This will be attenuated. Hence, which is called as the band stop filter. Then basically this is the 4 types of the filter should be given. We have seen there is a low pass filter, high pass filter, band pass filter and band stop filter. Then what is the actually realistic filter output, that part we have seen, and for the low pass filter, high pass filter, band pass as well as the band stop filter here, which is shown by this black line. That black line actually not immediately your circuit will be activated in realistic manner or in practically manner. Means your frequency slowly decreases towards the 0. Means here the low pass filter. In case of the high pass filter, after the lower cutoff frequency, your signal is slowly increases, and after the certain defined time or certain time it will be come to the stable position. So it is called as the high pass filter. In case of the band pass filter, what happened? For ideal case, it will be shown by here the red color. this will be shown by the ideal characteristics, means after the FL and after the FL and after the FH, the signal should be decreases or to be increases, and to maintain at FL to FH in this way. But in reality, after the FL, your frequency gradually increases, and at an instant, at a cutoff frequency here, f of c, it should be the maximum gain should be obtained. Okay, and after that, means up to the fc, it is the frequency is going to be increases, then your gain is also going to be increases. Means here the directly proportional relationship should be happen up to the cutoff frequency, and after the cutoff frequency your frequency is still going increases, and your gain should be going to be decreases. Means here is the inversely proportional relationship should be given. In case of the band stop filter, this particular band of the frequency should be attenuated. Suppose this is the one example in your class, nobody have to be studied and to be create the problem in a class, then there is a doesn't given the punishment for the all the students, but just we have to be remove the obstacles, then after that it's fine, then you have to be going to well study, because your whatever the obstacle we have to be removed here, just like the band stop filter. And the campus selection process that will be happen in case of the band pass filter, a particular band of the frequency which is to be happen, means here which student having the maximum gain at the middle frequency, then we are selected for that frequency only usable. After the cutoff frequency and before the cutoff frequency, there is a directly or inversely proportional relationship, and your frequency is going to be increases, then your gain is going to be decreases. Means here that will be impacted on the performance of the system. That's why we have to ignore it. Then passive filter, analog filter, it will be shown later on the ideal filter, sometimes called as the brick wall filter, and can be approached by making the order of the filter higher and higher. Then order there refer to the then it will be shown later on the ideal filter, sometimes called as the brick wall filter, and they can be approached by making order of the filter higher and higher. Then order of the filter higher and higher means you have first order filter, second order filter, means the x square of the n which is equal to, it will be varying from 1 2 3 4, this number of the order should be going to be increases, and its polynomial s will be used to define the filter. There are some MATLAB example will given later to illustrate this. Then up to the here we have seen that the basic concept of the active filter, just I have to be summarized here. Filter means unwanted, not to be useful components should be removed from the circuitry. Basically it will be categorized into the 4 types. First is the low digital filter and the analog filter. Means digital filter and analog filter, these are basically the 2 types of the filters. In case of the digital filters, we are most of the time to use the softwares, and with the help of the software to design it, to remove the unwanted things by using the digital filter. In case of the analog filter, there are some active analog filter as well as digital analog filter, and to use some discrete component, there is a resistor, inductor, capacitor, etc., and to removing it. Then your analog filter is categorized into the basically 4 types. First is the low pass filter, high pass filter, band pass filter, and band stop filter. Again we have to be go in further, there are again notch filter should be given, notch filter will be given, all pass filter is also given. This is the advancement, and sometimes there is a slightly modification in the circuitry and to design that all pass filter and notch filter, these, and there is some applications of the notch filter and all pass filter also. Then we have seen the ideal characteristics and the practical characteristics of the all 4 types of the filter. I hope that all of you understand these things. If any doubts, any query, please write on my comment page. then please you visit in our institute website. There is my contact number is given, as well as the email ID is also provided there, so you may be mail to me any doubts. And you have refer the some reference books. There is a Sudhakar Shamoon by network analysis, as well as the linear filters by Mujawar, Ishaq Mujawar by Satya Publications. Or any doubts you write my own personally also. Have a nice day. Thank you.